All right, Auto 2, I hope you're doing well. It's Monday and we are rolling along, and we're going to be looking at starting system testing. We already did starter current draw and cranking voltage, and that was where we cranked the engine uh, so it didn't start. We disabled the fuel pump and we cranked the engine and saw how much current the starter drew and what the voltage went to, and we found it dropped to like 10.9 volts, which is pretty normal. Between 10 and 11 volts is normal cranking system voltage. And the current draw, I believe, on the car that we checked was about 140 or 150 amps, which is very, very normal. What we're going to do today is we're going to do 3 tests, and we'll start down here. Number 1, we'll do what I call a starter signal test, and that's where we're going to use a test light to make sure that we're getting a signal at the starter motor, which would tell us that the ignition switch, the neutral safety switch, or the clutch safety switch, and the computer, if it's involved on the car, and the anti-theft system are all good, and we're getting a signal to the starter. So if we have a situation where we've got a car that's a no start, no crank, one of the first things we like to do is put on the rack or crawl under the car, get a test light right down to the signal wire that energizes the solenoid on the starter, and see if we've got a signal. So that if we don't have a signal, we know we have an upstream problem, meaning ignition switch, neutral safety switch, clutch safety switch, and or anti-theft or computer. If we do have a signal, we know it's a solenoid or starter system fault. The second thing we're going to do is we're going to look at starting system voltage drop, both on the ground side and on what's called the insulated side or the hot side. So we'll look at a voltage drop is measuring the resistance. So we're going to look on the ground side and on the insulated side to see if our cable connections, our cables, and our connections down at the starter are all good, that we don't have too much resistance that would impede current flow. We're also going to look at total system, starting system voltage drop, meaning the amount of resistance that's in the starter. So how much voltage is dropped or lost, pushing the current through the resistance of the starter field coils and armature themselves. Third thing we're going to do is we're going to do a starter free running current draw test, so that let's say we do our first test, we've got a signal, we do our second test, and our voltage drops are high, so meaning we have too much resistance. We're going to pull the starter off, put it on the free running current draw machine, and see how much current it's actually drawing. We expect it to kick up to about 130 amps and drop down to about 80 amps when it's free running, meaning it's not spinning the engine. A fourth thing we're going to do is I have a starter, and I think you can see this if I write it up here. The fourth thing that we're going to do is we're going to take apart a starter and a solenoid, and we'll look at cleaning contacts, because I got a starter that I pulled off a car that was an intermittent no crank. So we'll just put rebuild starter, and we'll also look at clean the contacts in the solenoid. So let me pause the camera and we'll move to the shop. All right, here we are out at the car. It's an '01 Dodge Ram, and it's got a 5.2 liter V8. I'm going to take the camera, I'm going to slide underneath. I've got my headlamp on, so you should be able to see what I'm doing. I'm going to take a bed of nails, which is a connector like this that's got, hopefully you can see those little nails in there. Let me see if I can get it to focus on it. Yeah, it did for a moment. Let's see. One more time so you can see these nails. There it is. Oh, it focused for a moment. Anyways, it's going to pierce over the wires I connect it. So sorry that wasn't so clear, but I'm going under the car. Hopefully I won't pull the camera from being plugged in. So I turn my headlamp on, and as we go underneath, you'll see I put new shocks on it. I did some new ball joints. Sorry, I hope I'm not getting you dizzy. Welded on a new catalytic converter right there. If you can see it, here's the starter motor, and pretty sure you're able to see this, so I hope I'm right. So here's the starter. Here's the big heavy battery cable coming down to the starter. Here's the signal wire, this 16 or 14 gauge wire. That's the signal wire. So what I'm going to do, and again, I really hope you can see this, I'm going to put the bed of nails over it. And then what I'm going to do is squeeze that so it pierces the insulation, hits the copper of the stranded copper wire in there. I think I've got it on there pretty solid. And we're going to go, I don't have anybody here to crank the car, so I've got to crank it. So what we'll do is we'll come up here. Oh, sorry. And I'll put this back here. I'll let that thing focus. I'll turn off my headlamp so I'm not blinding you. And put my glasses aside. And I'm going to take a test light and I'm going to attach the test light to that guy there. And so if I just touch ground and crank this car, I'm going to go ahead and come on in over here. And I'm going to grab the key and I'm going to hold this. Got the ignition on. I'm going to hold this to a ground. And I've got painted surfaces here, so I don't know if I'll get a ground. Maybe I'll scratch this bolt. And we'll see if this thing... So there it goes. So you can see the test light. Here we go. 1, 2, 3. You saw it. Obviously the car's starting. But what you also saw is you saw the test light light up. So let's say we had a car that was a no start, no crank. And we wanted to know if the thing was good upstream. Bad hair day, sorry. So if we wanted to know if the thing was good upstream, meaning the neutral safety switch, the ignition switch, the anti-theft, if we see that light go on, everything up above the starter is good. And if it's still not cranking, our issue's in the starter, okay? Obviously the car started, so this one doesn't have a problem. What we're going to do now is I'm going to stop the tape here and then restart. So that was a starter signal wire test, and obviously it was good. Now I'm going to take a digital voltometer, turn it to V for volts. Because it's an automotive meter, it automatically configures to DC volts. If I wanted to use it as an AC voltmeter, I push the blue button, and you'll see it says AC right there. And now I'm going to go ahead and push the button, and it's going to go back to DC volts. I'm going to make sure my leads are pushed in firmly so I get an accurate reading. I'm going to put this on top of this engine fuse box. And in order to do this, the starter, what I'm going to do now is the insulated circuit and ground circuit and total starter circuit voltage drops. I'm going to pull this fuel pump relay back out and put the cover back on because it gives me a nice place to put the voltmeter, so hopefully you guys can see it. I'll put the relay over here on the bench, so hopefully I don't forget. I'm going to drag this thing a little bit closer so you can see a little better and get that thing down there on that. I know there's a little bit of glare there in the meter, but hopefully we'll be able to see it. Right now it's saying 1.3 millivolts. I don't know if you can, I doubt you can see the decimal place, but anyways, it's just measuring voltage in the air. So let's do the total starting system voltage drop first. We're just going to put red to positive and black to negative on the battery. Remember, if you hook them up backwards, it's okay. It's just going to read negative. So the car's not, it might fire for a moment because there might be a little fuel left in the lines. But we're going to look at that starting system voltage drop. And I think I can see the meter from where I am cranking it. But you guys will be the ones to know for sure what it is. So here we go. Let's crank it. Okay, so I couldn't see it. So I'm going to pull it over here. By the way, resting voltage is about 12.1 volts. I'm going to pull it over here so I can see it. Okay, so it leveled out at about 10.93, and I'm going to do this one more time and bring the camera closer so you guys can see it. I'll just bring it right here and set it right here and put it right there. And you can see that. Here we go. So about 10.9 volts. Well, we had 12.1 approximately volts, and now we got 10.9. So the difference between the two is what we call starting circuit voltage drop. So let's say 12.2, which is reading right now. If I subtract 10.9, I've got 1.3 volts, right? 11, yeah, 1.3 volts. So the total starting system circuit is dropping 1.3 volts, meaning that's the amount of resistance, sorry, that's the amount of voltage that's being dropped, pushing the current through the starting system, okay? That's very normal. What we're allowed is up to 0.2 of a volt voltage drop per connection. So the connection at the positive side of the battery, the connection at the starter solenoid. There's actually 2 contacts in the starter solenoid, so that's 4, so that's 0.8 of a volt. There's the battery connection 5, and then down at the starter, and the battery connection here on the battery. So that's like 6 times 2, that's 1.2 volts of just connections. And we could have a little more, then the rest of it, we can have more voltage drop just in the field coil windings because they have resistance, and in the armature. So this one's got 1.2 volts total voltage drop, and just in the connections we're allowed 1.2 volts. So obviously there's no problem here, and the cranking speed tells us that things are just fine as well. So what I'm going to do now, that's total starting system voltage drop. We're going to look at the insulated circuit voltage drop by itself, and I'll unwind these cables, and I'm going to connect. It really doesn't matter which lead you connect where. It'll read positive one way, negative the other way. So there's the battery positive cable, and I'm going to go ahead and so there's our connection at the battery positive cable. So we're testing the integrity of this cable connection, meaning is there any resistance in there? And then I'm going to take the other lead. I'm going to put this down on the ground here. I'm going to get my headlamp back on. I'm going to go ahead and crawl back under the car and connect this to the hot side. And I'm just going to leave the thing running for a moment, get my headlamp on, hopefully quickly so you don't get bored to death. Turn my light on, get it to stay on, get my glasses, grab the camera, and we are going down underneath, and our goal is to attach the negative voltmeter connector down onto, so here we go, as I get you underneath here. Hope you can see where that battery connector connects there. And so I'm hoping that I'm holding the camera right because I can't see the screen. So you guys will tell me later what a loser you are, Lemkill, and I'll say, yeah, I know. It's really a bummer being me. Okay, so I'm taking this one off the signal wire now. Oh, just lost my connection. And I'm going to try and get it on there again. Let's see if there's a better way to do this. Can I spread the whole thing? Let's see. Yeah, it's on there. Okay. So I got that connection on there. And I'm going to slide back out because I got to crank the engine. And hopefully the connector stays on. And again, you're probably getting dizzy. So I'm going to go ahead and reach in and grab the meter. Get it up here where I can see a little better and where you can see it. Reach over and grab it, and I'm going to go ahead and crank it. Let's see what we get. So we got, it was down in millivolts. It was really low. I'm going to do it one more time up here where I can see it better. Here we go. It looked like 10 or 11 millivolts, but you'll also notice that it was fluctuating a little bit. So millivolts are really, really low amount of voltage. So I'm going to go underneath, disconnect it. The voltage drop on the insulated circuit's excellent. I'm going to go take the lead off and we'll do the ground circuit. Let me pause it so you don't get too bored. Give me 1 sec here. Okay, so I just realized that the reason why the voltmeter was fluctuating is because, guess what? My connection down below had come off. So I should have identified, whenever you see a fluctuating, very low millivolts reading, you know that you're reading just voltage in the air. So I went back down there and got it connected properly. And so I'm going to show you what the insulated circuit voltage drop is again. So I'm going to put the meter there, and I think you can see it while I crank it. Watch it closely, okay? Here we go. So you saw it around 270, 280 to 270 volts. Sorry, 280 millivolts or 287 millivolts. So that's 0.287 volts. And we said we could have up to 1.2. So the insulated circuit on this starting system is in fantastic shape. So again, I'm going to go ahead and disconnect that. Okay, and if you're watching this and wondering, hey, can we do this? Of course you can. Maybe not at home. Is it a little bit of a challenge to get down to the starter? Yeah, it is. Some cars are easier than others. Front-wheel drive cars, a lot of times they're easier than that. I'm going to do the insulated circuit now. And the insulated circuit, I'm going to go, well, the best place to go, and I know you can't see what I'm doing at the moment, but the best place to go is right on the case of the starter. And so I'm going to reach underneath again while you hang out right there and grab the case of the starter, which I am now officially on the case of the starter, and go to the ground side cable. And so now we're measuring from the case of the starter to the negative battery cable, and that's going to show us ground side starting circuit voltage. And I'll turn this like this, and I'll put the camera here because I think I can reach the key and get the screen on there. There it is. Here we go. So about 248 millivolts or 250 millivolts on the ground side. So again, sorry, I said before that we could have 1.2 on the insulated side. That was wrong. It's 0.2, maximum of 0.2 of a voltage drop per connection. On the insulated side, we had 2 connections, so we could have up to 0.4, and we only had 0.2, so 270. Here we have 287 or whatever it was. That's 0.2, and again, we could have 0.4 there. Actually, on that one, we could have as much as 0.6 because of the way the ground path runs. Okay, so that's starting system voltage drop, total voltage drop, which was about 1.2 volts. Insulated and ground circuit were both about 0.2 of a volt or 287 millivolts, which would be 0.287 volts. And then I did the signal wire test. I'm going to stop this one, publish it, and then we'll go to the free running current draw test next.